Hey, welcome back to class. I'm Miss Algebra. So glad that you could make it. Today we are talking about the distributive property. Go ahead and open up your guided notes if you have them. If you don't have them, you can access them at the link in the description box below. I'm going to go ahead and open them up on my end as well. Perfect. All right, let's start as always with our learning target. I can simplify or expand expressions using the distributive property. We will actually be talking about a little bit of both of those today. All right. As always, we're going to start with the do first. Today, they ask us to write an expression for each set of algebra tiles, and they give us a key here as well. So just keep in mind the shaded tiles are positive values, the non-shaded tiles are going to be your negative values. So, our first set of algebra tiles, I have two X tiles and I have three on each of these rows. So we have 2x plus 6. We will talk about looking at that row by row momentarily. My second set of algebra tiles, I have 4x² tiles, and I have 6 negative x tiles. So let's put minus 6x right there. Then our last one, we have negative 2x² plus 8. All right, so it looks like those are going to be our algebra tiles for the do first. Perfect. Moving on to our vocabulary section. I'm gonna slide over here. All right. For each of these, they kind of give us a big definition. I'm going to try to shorten it as much as possible, but this is what we are looking at. So for an expression is a math statement with at least two terms and one operation. So it has to have at least two things, two terms, and we should add, subtract, multiply, divide, take the square root, square it, something of that nature. All right, perfect. A term can either be a single number. In that case, we call it a constant. It can be a single variable. So like X or Y, or the product, meaning we multiplied of said constant and said variable, right? Or the product of constants and variables. Sorry, the vocab is long, but you need to know what we're talking about. All right. Factors are the terms that we are multiplying within an expression. So terms being multiplied in an expression. And to distribute means that we're going to multiply, except this time we're going to multiply across a sum or across a difference. So to distribute means to multiply across a sum or difference. We can use the distributive property for whole numbers, like for number only values, but technically it wouldn't make sense because we can just combine like terms if we were to do that and then just multiply by a single value. So the distributive property helps us multiply groups of items that are not like terms. And that's going to actually be our big idea today. So go ahead and write that down. I'm going to come back to camera so that you can see it. This is the big, big, big idea. Here's our big idea, okay? The distributive property allows us to multiply groups of unlike terms. So if I had something like 2x plus 3, I can multiply that entire quantity, 2x and 3, by some other amount using the distributive property. All right. Let's go ahead and write that in our big idea box. I'm going to slide down here right here. Distributing allows us to multiply groups of unlike terms. Remember that like terms have the same variable and the same exponent. Okay, before we do anything else, let's actually jump down and talk a little bit more about the distributive property. So I'm going to slide down right here. Here's our distributive property. If I have A times B plus C. Now remember I said if B and C were numbers, you could just add those two numbers together and then just multiply by A, and you don't really need to use the distributive property. It does help us when we're doing mental math or we want to break down larger numbers, but here is effectively how that works. We have A groups of B plus C, which means that we want to multiply A groups of B, so that would be A, B, plus A groups of C, plus AC, right? So we're just multiplying the factor that's on the outside to every term on the to the factor inside parentheses. All right, let's do it again one more time. If I have A times B minus C, so A is considered one factor and B minus C is also considered one factor, right? We're going to take A, we're going to multiply it times B because that's the first term in that factor. So this would be AB. And this time we're going to be subtracting A times C, or you'd multiply A times negative C, right? And you would get negative AC, same thing. All right. Let's jump to some guided practice. You have some frequent scenarios. So these scenarios talk about the different types of factors, the different ways that your factors can look in the distributive property. There's a hair somewhere and I can't find it. There we go. Okay. Sorry. All right. So our first scenario is going to be the scenario where we have a constant and a binomial. So the constant is 4. 4 is a number with no variable. And our binomial is an expression that has two terms that are not alike. So 3x is one of the terms and 9 is the other term. This is like the simplest, most easy case of the distributive property. So we'll continue to do it this way. You can break this down a little bit further if you wanted. So I will do that for the sake of this. We're going to have 4 times 3x plus 4 times 9. Remember that we're going to take the factor outside the parentheses and multiply it by each factor inside, each term inside the factor in parentheses. All right. So 4 times 3x, 4 times 9. 4 times 3x is 12x. And 4 times 9 is 36. So 12x plus 36. We have expanded this using the distributive property. All right, let's take a look at our next example. This one has a constant and a trinomial, but it's kind of hard to tell where that constant is because notice we just have this negative sign right here. That is an indication that we are technically going to be multiplying by -1. So if you want to draw a little 1 in there, you can totally do that. I like to read this as the opposite of, because the negative just by itself tells me that I want the opposite of every term inside the factor in parentheses. So I would multiply -1 times 2x squared. So opposite of 2x squared plus the opposite of 6x plus the opposite of -8, which seems a little wonky, but we've got it. Opposite of 2x squared is -2x squared, obviously. Opposite of 6x is -6x, and the opposite of -8 is going to be +8. All right, moving right along. This time we have a monomial and a binomial. So the two factors that we have, one factor has one term. So the monomial is going to be -5x. It's not a constant because it does have an x, it does have a variable there. So it's called a monomial, one term. Our binomial, again, has two terms that are not alike. And those are our two factors. One of our factors is -5x. The other factor is x minus 7. Same exact process. I'm going to do negative 5x times x minus negative 5x times 7. All right, negative 5x times x. I'm going to keep my constant, negative 5. This is negative 5 times 1. And then x times x is x squared, because we have two factors of x to account for. And then we have to subtract negative 5x times 7. So because I'm going to be subtracting a negative, or I'm going to be like distributing this negative here, negative times negative, I'm going to end up with a positive. So plus negative 5x times negative 7 is going to be positive 35x. All right. Next example, we have a monomial and a trinomial. So this time we have one term in our first factor, 3x, three terms in our second factor, x squared minus 10x plus 1. We are doing the exact same process. So this would be 3x times x squared. It's going to be 3x cubed this time. We have one factor of x in 3x and two factors of x in x squared. So that's going to be a total of three factors of x. Then we have 3x times negative 10x. In order to do this, we're going to multiply the two constants together. 3 times negative 10 is negative 30. And x times x is x squared. And then we are multiplying times 1. Anything times 1 is itself, so plus 3x. And we have successfully expanded that phrase as well. All right. Our last frequent scenarios are some that have non-integer coefficients. So in this case, the coefficient is going to be the factor that is outside of parentheses. Notice that neither of these is a whole number. What we are going to do is we are actually going to go ahead and multiply this out. 2/3 times 12. Now, if that's freaking you out, you can always multiply fractions. So 2/3 times 12. Every whole number is a fraction over 1. That lets me know I can just do 48. Sorry, that's not even 48. Who's your math teacher, bro? 24 over 3. 24 over 3 is going to be 8. So 2/3 of 12x is going to be 8x. And then I need to do 2/3 of 21. The other way I can do this is if I know what 1/3 of 21 is. So 21 divided by 3 is 7. So 2/3 would be two groups of 7. That would be 14. But again, I can do this the same way. Just do 2/3 times 21 over 3. Sorry, 21 over 1. Goodness gracious, Miss Bray. And we get 42 over 3, which is 14. My bad, y'all. This is why we practice. This is why we practice with the fractions, with the decimals, because they do get tricky and I don't want them to seem completely foreign to you whenever you encounter them. So I do want to make sure that you got that. Okay, I'm gonna take a little quick sip break of my lemonade. All right, and let's move on. Our next one, we have 0.5. M is going to be our distributed coefficient, so the factor that we are going to be multiplying out. 0.5 is just a half. So I'm going to be thinking of taking half of each of the coefficients in the other term. So, or in the other factor. So I'm going to say 1/2 of 7 is 3.5. And since they are using decimals, we're going to also use decimals. If the other one had resulted in fractions, I would have left those as fractions. So we have 3.5 because that's half of 7, and then m times m squared is m cubed. We have 0.5 times 16m, so half of 16 is going to be 8, and m times m is m squared. And then we have half m of -3. So half of negative 3 is negative 1.5, and there's no other factors of m to multiply. So that is that in expanded form. Perfect. All right, let's move on to the keep in mind section. Some things we want to make sure that we remember, don't forget as we are working through our problems. All right. Distribution or distributing allows us to blank an expression using blank. All right. So all we've been doing is rewriting or expanding. So rewrite or expand. You could use either word there. An expression using multiplication. That is the operation of the day. Multiplication. I promise I can spell. All right. The factor outside of the parentheses must be multiplied to every term inside parentheses. All right. And then we did not draw when we were doing the distributed property. I do like to do a lot of like doodling and drawing as I teach, but we can also model the distributive property using an area model. This happens a little bit more when you get into multiplying polynomials, but you can use an area model. Area model to show the distributive property even with just one term. All right. Before we go any further, just want to point out a common mistake. Don't want you making this mistake as you are working. The biggest thing that I see using the distributed property that people tend to mess up on, just the forgetting that you have to actually multiply every single term, right? You do need to do that. You have to especially be careful with your negatives. So that is going to be the common mistake that I'm going to write here. We're going to say forgetting to multiply or distribute every term. Distribute to every term. And then I'm going to put especially with negatives. You have to be really careful about those negatives. All right. In the try it out section, there's like two things or two sets of things that you're going to have to do. In the first set, this top set, you're going to complete the missing part of each expression. So you can go back to where we worked in the guided practice because I kind of did the same thing here. I broke it down for you based on like each factor being multiplied to the terms in the other factor. It says the first one has been done for you. Lucky duck, you have a good example. So for this one, we have -3 times 2x minus 5. We are going to break that down into -3 times 2x and then -3 times -5. And then that was how we got our expanded expression of -6x plus 15. So you guys are going to continue that process for the 3 across the top here. Then underneath it, you are going to decide if these statements are true or false. So what you're going to do is you're going to have to use the distributive property to expand the expression on the left, decide if it equals the expression on the right, select true or false. If it's false, then down here, you are going to correct it. So like write the original expression and then write what it actually distributes to whenever you find it. I'm going to give you a couple of moments and we'll talk about these. So you're already working ahead of me, which is great. No worries. Let's go ahead and get started. Okay, so this one is 12x times x plus 4. That means we're going to do 12x times x plus 12x times 4. Love that. They've already simplified it for us. Okay. The last two, we have to do all the work ourselves, but that's okay. Our first term to distribute is going to be x squared. So we're going to take 8, times x squared. Then we have that same factor 8 on the outside being multiplied to the next term in our second factor. So this is going to be 8 times 3x. And then we have plus 8 times 1. All right, that gives us 8x squared plus 24x plus 8. Beautiful. Our last one on this row has fractions as well. Again, I don't want you freaking out about the fractions. Remember that you do have space to kind of multiply it out. So here we have 3/4. So this is going to be 3/4 x times 4x squared. Okay. Then we have 3/4 x times negative 16x. And then we have 3/4 x times 8. All right. Now, lucky for us, all of the coefficients in our second factor can all be divided by 4. So that makes it easy when this is also being divided by 4. What we're going to do, I'm going to go ahead and show you guys the multiplication just to show you how it works out. But otherwise, we're going to start here. We have 3/4 times 4 over 1. So I could multiply straight across. 3 times 4 is 12, and then divide by 4. If I want to cross simplify, I notice that I have 4 as a numerator and 4 as a denominator. 4 over 4 has a value of 1, so that's going to eliminate itself. So we're going to be left with 3. So this is going to actually be 3x squared. So we want 3/4 of 4. Now we want 3/4 of negative 16. So I would say 3 over 4 times negative 16 over 1. I could cross simplify here if I wanted 4 and negative 16. This would simplify to 1. Negative 16 divided by 4 is going to be negative 4 over 1. So I've got 3 times negative 4 is negative 12 over 1. So I'm not going to put a plus there. I'm going to put a minus. Put minus 12x squared. I could put plus negative 12x squared. That would also work. Then I want 3/4 of 8. So I'm going to work this the other way. 1/4 of 8. 8 divided by 4 is 2. So 3 of those 1/4 is going to be 6. So this is going to be plus 6x. Woo. All right. You can do the fractions, just keep practicing with them. A lot of times with the fractions and the decimals, they will try to use the coefficients to make you feel a little bit anxious, but generally they will work out to whole numbers. So you shouldn't have to worry too much about them. All right. Zooming back in, we need to decide if the following statements are true or false. And then we're going to correct the false statements if we have any. All right. We have our first one says 2 times x minus 5 equals 2x minus 10. 2 times x is 2x. 2 times negative 5 is negative 10. 2x minus 10 equals 2x minus 10. This is true. Woo! Here's our next one. Looks a little bit more complex, but we got it. Negative 3y is the term outside our factor outside parentheses. Our factor inside parentheses is 2x minus 3. When we distribute, we're going to multiply constants first, then multiply variables. So negative 3 times 2 is negative 6. And then x times y, we don't have another special name for that. It's just going to be xy. So negative 6xy. And now notice that we're going to distribute to a negative number. So we have negative 3y times negative 3. So I have to do negative 3 times negative 3, which is positive 9. And then I just have y, so positive 9y. This is actually going to be false. And that is because theirs has a negative 9y there. So I'm actually going to rewrite this. So negative 3y times 2x minus 3 equals negative 6xy plus 9y. That's how I'm going to correct that there at the bottom. All right. Here's our next one. 1/2 of 6x plus 30 equals 3x plus 10. So that's easy because a half is an easy fraction to multiply. So I have half of 6x is 3x, and half of 30 is 15 plus 15. 3x plus 15 does not equal 3x plus 10. So this one's going to be false. And I'll do the same thing that I did for the last problem. Just rewrite it, right? 1/2 6x plus 30 equals 3x plus 15. Brilliant. Okay, last one on this row. 7 times 3x equals 21x. This one does not seem like it needs the distributive property, right? Because we're not adding the terms here, but it technically is an example of the distributive property because we have 7 groups of 3x. So again, we're going to multiply constants first. 7 times 3 is 21. And then I don't have a variable with 7, so it's just going to be 21x. And 21x does equal 21x, so that is true. All right. For the last prompt that we have at the bottom of the page, it says, in your own words, they want you to explain what is happening when we are simplifying 4 times x plus 3. All right, I'm going to leave you guys to that. If you have an answer, go ahead, type it down in the comments. I would love to hear your thoughts about this. This is not a question that really has a right or wrong answer, although there are bonus points you can get if you say the right words, if you know what you're talking about. So I would love to hear what your suggestions are without using the words distribute or multiply. Explain what is happening when we simplify 4 times x plus 3. All right, it's a great prompt to leave off on. Let's come back together. All right, I hope that that was able to kind of clear up some of the distributive property for you. I really wanted to make sure with this lesson that we talked about fraction coefficients, we talked about decimal coefficients, that, you know, you got some really, really good, good examples of all of the different scenarios that you may use the distributive property in, at least with one term being multiplied by some collection of other terms. Um, yeah, that's all I got for you today. Sorry. I don't really have like a whole intro outro situation. Like I said, if you want to get the lesson that we use here, you can access those materials at the link in the description below. Like, comment, share, subscribe, all of that good stuff. I guess I will see you next class. Bye.